Here we will explain the concept related to single tuned capacitive coupled tuned amplifier. Single tuned capacitive coupled tuned amplifier. Single tuned capacitive coupled tuned amplifier. Circuit diagram. Transistor. These two are bias and resistances R1 and R2. This one is emitter resistance RE, emitter bypass capacitor CE. This one is source resistance RS. This one is VS. Here load resistance is replaced with the tuned circuit, consists of L and C elements. Consists of L and C elements. C, L, R connected here. Plus VCC. For high voltage gain, we use second stage. By using first stage is connected to second stage through this coupling capacitor CC. This is the another stage. Inter bypass capacitor CE and RE. Here this one is a second stage. This one is stage 1. Next to this one is stage 2. Our next stage. The input resistance of the stage 2 is here is RI. Here the voltage is here VA. The voltage is VA. This is stage 1 and stage 2. This one is next stage. Next stage. This is the collector terminal. This is a single tuned amplifier uses one parallel resonant circuit. This is the parallel resonant circuit has a load impedance. Here generally we use RL. RL is replaced with some tuned circuit. Consists of C, L and R elements. A single tuned amplifier uses one parallel resonant circuit as the load impedance. In each stage, and all the tuned circuits are tuned to same frequency. All tuned circuits are used in the next stage is tuned to same frequency. This is the description. The output across the tuned circuit is coupled to the next stage through the coupling capacitor CC. This is the tuned circuit. The output across this tuned circuit is coupled to the next stage through this coupling capacitor CC. Tuned circuits formed by L and C acts as a collector load and resonates at frequency of operation. Resonates at a frequency of operation. Resistors R1 and R2, RE, along with the capacitor CE, emitter bypass capacitor CE, provides the self bias for this circuit. The transistor is replaced with equivalent hybrid pi model. This is the transistor is replaced with equivalent hybrid pi model. The equivalent circuit for the equivalent circuit for single tuned amplifier using hybrid pi model. This is the hybrid pi model. This is the base terminal B, RBB dash, base spreading resistance. Here B dash, RB dash E here. And the capacitor here is CB dash E. Next one is here CB dash C. Here RB dash C. This one is a dependent current source. The value of this dependent current source is GM into VB dash E. Generally, we use diamond shape. Next one is here GCE. This is the equal hybrid pi model. Hybrid pi model consists of resistive effects and capacitive effects included in that circuit. One dependent current source also included in that circuit. Here VA is there. Here VA. Generally, we use one capacitor here, C1. This is the coupling capacitor at the input stage. For AC analysis, this capacitor is replaced by short circuit. Here, VS and RS is connected here. VS and RS. At the base terminal, VA is there. VA. For AC analysis, set DC is equal to 0. That means VCC is equal to 0. The CL acts as a load for the circuit. This is also included in this circuit. Here, this one is C, L, and R. This is the output. Output V0. The output across this tuned circuit is coupled to the next stage through this coupling capacitor CC. That is the reason it is called as a single tuned capacitor coupled tuned amplifier. These CB-C and RB-C is connected to both input side as well as output side. Miller's theorem is used to replace these two. According to Miller's theorem, an impedance Z is connected between two nodes, the node 1 and node 2. Node 1 and node 2. According to this Miller's theorem, it is replaced by, at the input side, it is replaced by Z by 1 minus A at the input side. Node 1, this is the node 1. Not 0 here, 0 is not used. Node 1. Here node 2. Z A by A minus 1. Where A is called as voltage gain. Where A is called as voltage gain. Here two elements are there. Here first element is at the input side, and the input and output is connected to this is the RB dash C between input side and output side. Input side and output side of the circuit is replaced with according to Miller's theorem. This one is Miller's theorem. This RB dash is divided into two values. First one input side is at the input side, the value is RB dash. That is RB dash C by 1 minus A. At the output side, the value is here RB dash C, RB dash C, A by A minus 1. A by A minus 1. RB dash C is replaced with 2 according to Miller's theorem. The RB dash C is split into two resistances. That is one at the input side and another one is at the output side. RB dash C by 1 minus A, RB dash C A by A minus 1. And similarly, this capacitance at the input side, output side, this one is a CB dash C. According to this CB dash C is replaced with two capacitances. At the input side has one capacitance, at the output side has another capacitance. Input side capacitance is suppose Z by 1 minus A. Here Z is impedance of that capacitance CB dash C is 1 by Z is 1 by J omega CB dash C into 1 minus A into 1 minus A 1 by J omega. Let the CB dash C into 1 minus A is C1. CB dash C is 1 minus A is C1. Therefore, at the input side, the capacitance is C1. Input side, the capacitance is C1. Similarly, at the output side, ZA by A minus 1. ZA is 1 by J omega. Z is this one element. The reactance of that capacitor is J omega CB dash C A by A minus 1. 1 by J omega CB dash C 1 by J omega CB dash C A minus 1 by A. A minus 1 by A. CB dash C A minus 1 by A is C2, 1 by J omega C2. At the output side, the capacitance value is C2, where C1 is CB dash C into CB dash C into 1 minus A, where C2 is CB dash C A minus 1 by A minus 1 by A. Therefore, this circuit is replaced with equivalent circuit here is Vs, Rs, Vi, Vi, here base terminal here, RBB dash. Here RB dash E is there, base spreading. RB dash E. The input side circuit is like that. Here CB dash C is also there here at the input side. At the input side here, CB dash C. One more resistance is there, that is at the input side. This RB dash C is common to both input side and output side. According to Miller's theorem, this RB dash C is divided into two resistances, RB dash C by 1 minus A. Here, RB dash C by 1 minus A. And one more capacitance is also there, that is CB dash C. CB dash C is at the input side is C1. This is the input side circuitry. At the output side here, at the output side, GM into VB-C, dependent current source. And again here at the output side, RB-C into A by 1 minus A. RB-C into A by A minus 1. RB-C into A by A minus 1. And the capacitance is C2 here. And capacitance is C2. And capacitance is T2. GCE. 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 Here GCE. And CLR, tuned circuit. Tuned circuit acts as a load for this circuit. This one is C, L, and R. The output is like that. This one is output V0. Again, here at the input side, one more capacitance is added here, that is input stray capacitance. Input stray capacitance, that is CSI, input stray capacitance. At the output side is also added one more capacitance, is wiring capacitance. CSO, stray capacitances are wiring capacitances. Therefore, at the input side, CA is equal to these three capacitors are connected in parallel. CB dash E, CB dash E, and here plus C1 plus CSI. At the output side, C equivalent is equal to CB dash E, CB dash C into A minus 1 by A, that it be C2. C2 plus CSO plus C is there, plus C is there. These are the capacitors are included at the input side and the output side. This one is RB dash C, high low value. This resistance is due to forward bias of the junction at the input side, low value. RB dash C is the reverse resistance due to reverse bias at the output side. 1 minus A, where A is called as GM into RL, minus GM into RL. 1 minus of minus. Here RB dash C by 1 minus of minus GM into RL, depends on load resistance. RB dash C by 1 plus GM RL. This is the high value. This one is low value. High value in parallel with low value, that is equal to low value. That is equal to low value. RB dash E, low value, parallel with RB dash C by 1 minus A, high value, is approximately equal to RB dash E. Approximately equal to RB dash E. At the input side, these CA and RB dash E included in that circuit, along with RBB dash. Coming to output side, GCE is there. GCE is there. GCE, according to derivations of that hybrid pi equivalent circuit, GCE is equal to 1 by RCE. This one is conductance, that is equal to 1 by RCE. We know that generally the formula is HOE into HOE minus GB dash C HFE. HOE minus GB dash C value is HRE by RB dash E into HFE. HFE. HOE HFE by RB dash E is GM. GM into this is the GM. This one is HRE. Finally, HOE minus GM HRE. GCE is equal to, is approximately equal to, this value is neglected, HOE. This value is neglected, HOE. Say 1 by R0. Say 1 by R0. Say 1 by R0 included in that circuit. Included in that circuit, equivalent circuit. Therefore, here R0 is equal to 1 by HOE. By using these approximations and replace the circuit, equivalent circuit is like that. VS, RS, here B, here VA, RB dash C is parallel with RB dash C by 1 minus A is approximately equal to RB dash C. These two are here, this one and this one is replaced with RB dash C. Here some base spreading resistance is also there. Here some base spreading resistance. RBB dash. Here B dash. Here RB dash E. The voltage across RB dash E is VB dash. VB dash E. The voltage across RB dash E is VB dash E. Here CI, another capacitance is CI at the input side, included CB dash E, C1 and CSI, wiring capacitance and stray capacitance. Here at the input side, that is here is CA, and the dependent R naught is equal to 1 by HV. At the output side, some dependent current source is there. Diamond shape we use here, GM VB dash E. Here RB dash E A by A minus 1. Here another capacitance is C equivalent. C equivalent includes C2, that is C2, C and CSO. C2, CSO, output stray capacitance, and C includes here C equivalent, includes C equivalent. GC R naught, one more element is also there, that is included here. R naught is equal to 1 by HOE. R naught is equal to 1 by HOE. Here RB dash C A by A minus 1 by. This is the low value. This one is RB dash C A minus 1 by A by A minus A by A minus 1. These two are replaced with R naught, and L R is there. One more here is added, that is input resistance of the next stage is, that is Ri. Input resistance of the next stage, that is Ri. Across this Ri is V naught. See this figure. Ri is the next stage input resistance included in that circuit. For AC analysis, this capacitor is replaced by short circuit. This entire one is replaced with R naught. Final equivalent circuit is here is at the input side. At the input side, this one is VS, RS, VI, B, RBB dash, B dash, RB dash E. This one is VB dash E. This capacitance is CA. This one is GM VB dash E. R naught, this is low value, this is high value, low value in parallel with high values, that is R naught. C equivalent. C equivalent. Next one is L, R, RI, RI. This one is across, this one is V naught.